So hello again. We are back to provide progress in our senior project in regards to the wireless power transfer. We already spoke about the abstract last time, so we're going to move on from that. And this is our project progress at the moment.
So since the last time we spoke, we've created three new receivers. We've created a copper tape one, which got 90% efficiency, a silver thread one, which got 10%, and then we also made one with silver thread and then a layer of epoxy on top, and that one got 30%. So right now we're working on a bigger receiver. It's because the problem we're having with the thread was that the resonance frequencies were matching up. So we're gonna try to make it bigger and see if that will match up the resonance frequencies. And the rectifier and the filter are now working. And the next steps, we want to try and make a new receiver with a new material that we got. It's a new thread. It's called Liberator 40, and it has much better conductivity or resistivity, I mean. It has 1 ohm per foot versus 300 ohms per meter that the other one had. So next, we want to study the misalignment, and we want to work on creating our demonstration for the final presentation. That's pretty
Yes.
much it.
So you said the rectifier doesn't work?
It does work, but it has very bad efficiency. At least the ones with thread have 10%, and then we made another one with thread with a layer of epoxy on top, and that one got 30%. But we
No,
have one.
he
Wait.
asked for the rectifier, not
No, no,
the
no, no.
Oh,
the
sorry,
receiver.
sorry, sorry. Laser receiver. Yeah, the rectifier worked.
Oh, it worked. Okay.
Yeah, it worked.
Didn't we have to get an amplifier for it? Or
Yeah, but that's like at the end.
gotcha.
Okay.
All right, so this is our project status, but we have that still as the same. Block diagram is still the same.
Hmm.
And then our individual contributions. So with me, I've conducted multiple trials with creating the receiver ring. I did update the design because I did want to try to keep the transmitter from misaligning with the receiver. So this is the receiver. It's much bigger and it's more like in a hexagonal shape per se. So I'm gonna try to work with that to see how it could be more efficient in regards to that. Other than that, I've ordered new materials for the receiver to see if they're able to if it's compatible with our products. I've contacted multiple companies in regard to their high-tech threads, such as MG Chemicals, Electrica, I believe. It's the Switzerland company. I've reached out to them, but they don't do samples, unfortunately. So the next best that I did was Syscom Advanced Materials, as we spoke about. I received their filament count of 40 with their Liberator, which I have right here,
Hmm.
which we should be testing this out. I would say not this week coming up, but in the next week because I want to have like the final design changes and all of that before using this product right here.
Hmm.
Our second best that they also provided was the Lo-Fi that I have here as well. So we're gonna try to work with those products to see if it can increase in efficiency instead of like copper tape because it is a little more delicate than thread.
Hmm.
So with these products here, we're gonna try to our best to use them a little later before final production and demonstration. Um, Other than that, I've done the design changes and the future plans is to fabricate additional receivers and as well as the jacket as the shirt for demonstration. We're also probably gonna have like a stand as a demonstration just in case. But other than that, that's pretty much it on my end.
Great. Why did you pick the hexagonal? Because it's easier to use it with the machine instead of
Also,
circular or
Um, because the reason why I changed the design to this is because I've looked up multiple research on antennas on how they work, as well as few other research that they've done already. And most of their shapes they have done circular, but the best results that I've seen is with a hexagon shape.
okay.
So that's why I changed it a little bit because based on those results, I can look up those studies and send them to you later. That based on that shape there, it's much better than the other circular shape because when it comes to like misalignment and stuff like that, it doesn't do that as easily as
Hmm.
rather than a circle.
Okay.
Mhm. And then Lydia.
So initially, I was responsible for creating the AutoCAD design that served as a foundation for the fabrication of the stainless steel conductive thread on fabric. After we passed that part, I was basically overseeing the fabrication, the testing, the soldering to learn from the process and ensure that the design was working as expected. Since we didn't get the expected results with the thread, with the stainless steel thread, I decided to take a different approach and create this sample here that you can see in the image with the copper tape and on fabric. That was pretty much it.
Okay.
Um,
So I've been working on new simulations. I wanted to have a more accurate simulation with the thread. So I used the 300 ohms per meter and I changed that into conductivity to see what what ANSYS would result in. And it kind of matched up with what we got in real life. It was like 4%, 5%. In real life, we got like 10% or something.
Nice.
And I've also been working on a bigger receiver. We wanted to make it 1.25 times the size to see if that will fix the resonance frequencies because how we have it now, the resonance frequency is at like 67 megahertz and then the other one is at like 2 gigahertz or something like that. It's like way off.
Ooh, okay.
So, and then I've also been soldering. I soldered that copper tape one, and then I've also been soldering on the fabric. But the problem with the fabric is that since I guess it's not metallic enough, or it's just so poor that it doesn't even bind with like the flux. It
Mm,
just pops right off.
yeah. So you said that the frequency is 2 gigs?
Yeah, it was. I think Javier. Do you remember if it was 2 gig?
Yeah, the for the fabric, it was in the gigahertz range, and then for the Rogers, it was in the megahertz range.
Yeah.
That's why we were told to increase the size of the fabric, because we were told that as the antenna gets bigger, the resonant frequency would decrease. So
Right.
that's why we're trying to increase the size of the fabric to try to match the resonant frequencies better.
Yeah, it's just very strange to have so high frequency. I mean, from you're expecting to be in the range of megahertz and now 60 megahertz or so, or I don't know, 30, 20 there. And
Mhm.
then 2 gigs, it's like thousands of times more, which means that if you take the theory, this design should be thousands of times smaller, which is not thousands of times smaller. So something else is wrong
Yeah.
or is off.
Yes.
I have to see the results probably.
Oh, so you're saying if the results are accurate, then we would have to make it smaller, not bigger?
No, you have to do it bigger, but I would expect for something to resonate at 2 gigs, it should be this small, even smaller from what I
Yeah.
saw.
Yeah, yeah.
You didn't do something like this small, right? You did something that's this big,
Yeah,
correct?
yeah.
So this, just based on the size, I would expect to be in the range of megahertz. But if you're telling me that this size operates at gigs, then
Hmm.
something else is off. It's not the size. Something else.
I think that fabric is just so bad that maybe it's like I'm not sure.
Yeah, that's very strange. But when you put copper tape, then this size operates at the frequency that you're expecting
Yeah.
to operate, right?
Hmm.
Yes.
Hmm.
So, okay, the deviation happens only when you use the thread.
Yeah.
Yeah.
Yeah, we tried soldering onto that thread and it doesn't even it just burns. It burns like as if it was just like as if it was just a fabric, as if it wasn't even like
Yeah.
metallic. It's weird.
So you're trying to solder the capacitor, you mean?
Yeah.
Yes.
Well, maybe you can try to connect it with copper tape just temporarily and see if it works, if it
Mhm.
resonates at the, you know,
Mhm.
desired frequency,
Mm,
just to see if the soldering is off or something. It cannot be the size. I mean, cannot be the size. I don't think it's the fabric the problem, because you use fabric and copper tape and it works fine.
Mhm.
The thread might be the thread, maybe the density of the thread is not big enough, but still it shouldn't resonate at high frequency. So somewhere else is the problem.
okay. We
If you
still have.
go, what you can do is you can, I think you did that, right? You put copper tape on top of the thread, right?
Yeah.
Underneath the thread, but we can put it on top.
You can just put copper tape on top of the thread and see if this thing resonates at the frequency that you expect to resonate. If it does resonate, then the problem is not the size,
Gotcha.
which this is what it should be. I mean, it cannot be the size.
Yeah. Okay. Are
You
we
can
So you
try to make it,
recommend
in theory, yes, you try to make things bigger to resonate at a lower frequency, but I don't think that the problem is there for this, just by seeing the size.
Yeah.
so you recommend we take the image that's on the right and just put copper tape on top of it and to test it?
Just to test, correct, to see if it
Okay.
resonates at the lower frequency.
Okay, we should do that.
Mhm. We have an extra one, so we can do that. This Friday, Monday or Tuesday.
Mhm.
Mhm. Oh, will you be there, Constantino's
I
on?
am here always. You can just
Okay,
stop by my office.
gotcha. Perfect. And then
Okay,
we'll
thank
let you
you.
know with the results.
Mhm.
Then Javier.
Oh, okay. So for me, my contribution was I troubleshooted the circuit diagram. That the circuit diagram's in the next slide that Geo constructed, but I was troubleshooting it, solving any hiccups, errors that I was having in the multi-sim simulation. I also tested the rectifier with Anastasios. That's you can see that in the picture. This is actually well, the picture's actually testing the copper tape with the Rogers. This is where we got like the -1 decibels efficiency between both of them. But we didn't take a picture, but it was also I also tested the rectifier to convert the AC signal to DC, and it worked.
Okay.
Mhm. And I think that's
How
it
mu
for me.
how much DC do you produce? Did you measure? Did you use a
Uh,
volt?
we we didn't measure it exactly, but we did get a signal. I think it was the problem with this is that we need minimum 3 volts to power our Arduino, which is like the whole point of the project.
Mhm.
But the waveform generator that's in the lab only produces 2 volts. So we were gonna talk to you at the end of the lab to maybe like connect it to an amplifier before putting it through the antenna to raise it up because we need at least 3 volts.
Mhm.
So minimum the amplifier is like 50% efficiency, like if it works perfectly,
Yeah.
which we didn't. I don't think we got it to where it's like 48% efficiency that we got.
Mhm.
So we need out
Yeah.
more from the source.
Yeah, you
So
can
we
do
wanted
that.
to
I
talk to you
talked,
about that.
yeah, Anastasius asked me, and they said you can use any of the amplifiers that we have there,
Mhm.
and you can increase the, output power, so you can get more on the other side.
Yes.
Yes.
Perfect. Okay. All right. And then Giovanni.
Okay, hi
He's
guys.
oh there he is.
Yeah, sorry guys, I have to be outside. So I've been working on the rectifier, the low pass filter. Um, we got the simulation. We did the multi sims. We tested it out. I went ahead and soldered it all together. I believe they tested it out yesterday. Right now, I'm in the process of working, actually completing the application, the app through MIT App Inventor to have the Arduino wire to Arduino to show the data of what the Arduino is collecting. The other thing I'm working on also right now is the heartbeat monitor. I already had it connected. I did create a program for it. I just cannot get it to be accurate. It seems to be very sporadic. So it's something I'm still troubleshooting.
Okay.
Mhm.
So what type of data do you try to get? You said heartbeat?
Yes, we have a heartbeat sensor, and it also includes a oxygen sensor. Right now, I'm just
Okay.
working on the heartbeat. With the Arduino includes a temperature sensor, motion sensor, and a couple other sensors. But right now, my focus is the heartbeat and temperature.
Which sensor do you use for the heart rate? Do you remember?
No, I could look it up real quick.
That's
I
fine.
mean,
It's okay.
okay.
Don't worry. It's all right. That's fine.
Okay.
The
The heartbeat sensor does run in 3.3 volts or 5 volts also, so it is compatible with Arduino.
Okay. That's fine. Great.
Okay. So this is video feedback from Professor Arellano, Senior Design Professor. Basically that the camera needs to be positioned to adjust at the speaker's level, and the video should be presented in full size to enhance clarity. We need to, according to him, we didn't follow the guidelines established, so we need to work on that as well. And it didn't include the project demonstration, which I'm assuming it's basically the final project demonstration that we need on that. So
Right.
we're still working on that, but probably by next video we'll be done with that and presenting it.
You didn't present anything in the previous video? Like any
I mean, we did. I don't know. His grading skill is, I wasn't sure what he was grading on because we did present a few things like in regards to um the recent receiver that we made. We even showed video of it demonstrating it, that it only did 10%, but unfortunately, like, we're working our best to do like higher efficiencies. So we had to go back to the drawing boards and stuff like that. So we presented a few things, as well as the rectifier that Giovanni did. So we're not sure what kind of demonstration he was talking about, but
okay.
we did present some of the stuff that we, progressed on in the meantime. So yeah, it's a little, I guess, miscommunication between us too.
Yeah,
So
okay.
yeah, but we did present a few things and we did, try our best with the video.
All right.
And then this is our logbooks that we did within the month and the weeks. So yeah, that's pretty much it. Any questions, concerns?
No, I mean we discussed already. No, I don't have any other questions or comments. When you come back to FIU just and you try to do the things that we discussed, you can come over here and let me know
Okay.
so I can come